Students, good morning. Today we'll continue the non-aqueous solvents. So under which we discuss about reactions in liquid ammonia. Okay. So the first one, autoionization. That means similar to water, where water undergoes dissociation to produce H plus and OH minus. In the similar way, ammonia also undergoes autoionization or self-ionization, producing NH4 plus ions and NH2 minus ions. Say if you take only one molecule here, there is a liberation of H plus. When ammonia undergoes dissociation, produces H plus and NH2 minus. But H plus is very active species and it readily combines with one more molecule of ammonia to give ammonium ion. So similar to water, in water also H plus is very active and it readily combines with H2O molecule and exists as hydroxonium ion. Say H plus combines with H2O to form this ion, that is H plus is always exist in the form of hydronium ion or hydroxonium ion H3O plus. Say even here also H plus ions combines with NH3 and exist in the form of NH4 plus ion. See, this is autoionization, but in water it is to the larger extent, and compared to water here it is to the lesser extent. That means undergoing autoionization or self-ionization is less compared to that in water. Okay, or that of water. The second next one is say acid base reaction. So in water you are well familiar, say when the H plus ion combines with OH minus ion gives water, isn't it? Or when acid combines with the base gives salt plus solvent, is it? So this is the basic relation. Any acid when it is mixed with base, it gives a salt plus solvent molecule. So in water, suppose NaCl is NaOH or a HCl in water, when HCl is mixed with NaOH, so you are well familiar, it gives NaCl salt plus water, is it? In the similar way, say in ammonia, the compounds which produces NH4 plus ions, they are acidic in nature, and the compounds which produces NH2 minus ions, they are basic in nature. So any compound containing NH4 plus ions are considered as amino acids, and any compound which contains NH2 minus ions, they are said to be amino bases. So the acid base reactions, so here when the ammonium nitrate is combines with the potassium potash amide, so here the ammonium nitrate acts as an acid and it acts as a base, and here it is a salt, and see solvent molecules are released. So the reactions between acid and base gives salt and water even in the liquid ammonia. So any acid, any amino acid, when it reacts with the amino base gives salt and that means solvent molecules. Okay, so it is very much similar to that happens in aqueous medium. Any acid plus any base gives salt plus water molecule in water. So now we'll move on to the next one, precipitation reaction. So here precipitation reaction, say there are certain, that means the precipitation reaction here it is important because say there are the compounds which are the solubility of which one is different in different solvents. So the compounds which are soluble in water, they may not be soluble in liquid ammonia. Similarly, those which are insoluble in water, they are soluble in liquid ammonia. For example, say here AgCl. You are well familiar when KCl is added to AgNO3 solution, silver nitrate and KCl solution. When they are mixed, you are getting a white precipitate, that is silver chloride. You have seen, isn't it? Say that is in water medium where KCl solution is prepared in water, AgNO3 is prepared in water. When you mix these two, say it gives a white precipitate of AgCl and KNO3 that remains in solution, that means in the dissolved state. Here it is insoluble. AgCl gives precipitate in the sense it is insoluble in water, is it? So now the same reaction, but we want KCl solid form, or we need the precipitate of KCl, which is not possible in water. And the same reaction, that means say when the AgCl is mixed with KNO3, AgCl when it is mixed with KNO3 in liquid ammonia, it gives precipitate of KCl. So this is not possible in water, but in a liquid ammonia the precipitation of KCl is happens with the liberation of AgNO3. That means KCl is insoluble in liquid ammonia, but the KCl is soluble in water, is it? So now during this reaction, AgCl is dissolved in NH3 and prepared its solution. KNO3 in liquid ammonia prepared the solution. Similar to the previous one, here KCl is dissolved in water, AgNO3 is dissolved in water, then they are mixed to get the precipitate. In the similar way, AgCl and KNO3 in separately, they are dissolved in liquid ammonia, and when they are mixed, we are going to get white precipitate of KCl. There are many number of reactions, many number of reactions, so which are normally not possible in water, and they are possible in liquid ammonia or in some other solvents. See here, this is the one of the example. So that depends on the solubility of the compounds. It's okay. They are different in different solvents. Hence, say by making use of non-aqueous solvent, that is ammonia, such reactions can be conducted, and which are useful even in the research field. So ammonolysis. The next one is ammonolysis. Ammonolysis is very much similar to salt hydrolysis, is it? Say salt hydrolysis already have learnt, is it? Say salt hydrolysis is nothing but reaction between salt and water, or it is nothing but ions of salts reacts with the ions of water. Ions of salt reacts with the ions of water is said to be a salt hydrolysis, and as a result there is a variation in concentration of H plus or OH minus in aqueous medium, that is during salt hydrolysis. There is a variation in either hydrogen ion concentration or OH minus ion concentration due to salt hydrolysis, and the resulting solution may be acidic, or it may be basic, or it may be neutral. So in the similar way, ammonolysis is nothing but is the reaction between salt and ammonia. As a result, the concentration of either NH4 plus may increase or decrease, or vice versa. NH2 minus ion concentration may increase or it may decrease. If it increases, this will decrease. If this increases, this will decrease, isn't it? So they are interrelated. So as a result of interaction of ions of salt with the ions of ammonia, ammonia are nothing but, so these are the ions giving the products, and as a result one of the ion concentration will increase, and that is said to be ammonolysis. Okay, it is said to be ammonolysis. Is nothing, it is very much similar to salt hydrolysis. Okay, so with this we'll move on to the next one, ammonation. And even here also ammonation is very much similar to hydration. So copper sulfate, anhydrous copper sulfate is colorless. This salt is colorless, but when it absorbs and when it gets hydrated with 5 moles of water, so it gives a blue colored complex. So that is copper sulfate. So blue colored compound. Similarly, there are more salt is there. Say carnallite is there. So there are many examples. Potash alum is one of the example which absorbs say 24 moles of water. Say it is said to be hydration. So similarly, even in ammoniation, say there are compounds which absorbs ammonia molecules and forms ammoniated. So it is said to be a ammoniated molecules. Say they are the adducts, that means addition compounds. So BF3 plus NH3 gives addition compound, or it is a ammoniated compound. So similarly SiF4 silicon tetrafluoride plus 2NH3 gives SiF4 plus 2NH3. Okay. Now with this we'll move on to the next one, proteolysis. See, proteolysis means there are certain compounds which do not produce protons or electrons in the water media, and they are producing or donating protons in liquid medium. For example, that is said to be a proteolysis. For example, urea. Urea is not reacting with water, is it? It doesn't undergo ionization, or say it doesn't donate protons in water. But in ammonia, it donates the proton. So it is a weak acid, acts as a weak acid, and it donates a proton to ammonia. Ammonium ion is formed, and see, this salt ion is formed, and this salt ion is very stable due to the resonance. See, the shifting of electron takes place, and it is said to be a stable ion, or it's a resonance stable ion. Okay, so there are many examples. Sulfonamide is there, acetamide is there. See, they do not donate proton in water, but they are ready to donate proton in liquid ammonia. Okay, that is proteolysis. So with this we'll go for the next one, that is leveling effect. So leveling effect is effect of the solvent on acidic or basic nature of some compounds. So either it may increase or decrease. For example, HCl is a strong acid in water, but it is a weak acid, or it is a normal acid in liquid ammonia. So it is the strength of acid is decreased. So in water it is strong acid, but in liquid ammonia it is a normal acid. And where acetic acid, it is a strong weak acid in water. Acetic acid is a weak acid in water, but it is a strong acid in ammonia. So it is said to be the acidic or basic nature. Similarly, soda amide, it is a weak base in water, but it is a strong base in ammonia. So labeling, this is said to be labeling or equalizing the properties, acidic or basic properties in liquid ammonia is said to be labeling effect. So the next one is complex formation reaction. Similar to complex formation in water, even in the liquid ammonia, complex formation reactions can be conducted. So one of the example, AgNO3 plus KCN, when it is added, silver cyanide is formed, and excess of KCN leads to the formation of a complex. Okay, so we'll discuss about the solubility. These are the salts which are soluble in liquid ammonia, and these are the salts which are insoluble in liquid ammonia. So we'll continue in the next class. Thank you.